Now in this example, you'll be told, use the method of undetermined coefficient to solve the differential equation d squared y over dx squared plus 2dy over dx plus 5y is equals to 34 cos 2x, given y is 18 and dy over dx is 0 at x is equals to 0. So when you want to use the method of undetermined coefficient, that is the d factor method, the d factor or the d operator. So if you want to use the d operator method, we will start by you let y to be equals to u plus v, where u is the complementary function and v is the particular integral. So where there is y, you will be substituting with u plus v. Then you separate u equation on this wrong and v equation is wrong. And we say where there is y, first you put u. So if you put u where there is y, you are going to get d squared u over dx squared plus 2 du over dx plus 5u. So the first part where there is y, you put u, then it is plus. It is plus. Then now where there is y, you now put v, isn't it? Where there is y, you now put v. Then we are going to have d squared v over dx squared plus 2 dv over dx plus 5v to be equals to, so on the other side of the equation we have the function f of x. So you put it as 0 plus 34 cos 2x. Are we together? Yes. Now the first part of the equation you compare. The first equation you equate to 0 to form the non-homogeneous ordinary differential equation. Then the second equation you compare with the function which was given, and the function you were given there was 34 cos 2x, isn't it? So the first equation we are going to have d squared u over dx squared plus 2 du over dx plus 5u. You compare it to 0. Then that forms equation 1. That forms equation 1. Then the second part you compare to the function. So the second part is this equation, which is d squared v over dx squared plus 2 dv over dx plus 5v is equals to the function, the second part, which is 34 cos 2x, Roman number 2. So we want to start by solving the first part, which gives us the complementary function. So the part which gives us the complementary function is the part where we have d squared u over dx squared plus 2 du over dx plus 5u is equals to 0. Now you let d to be, so you let d to be d dx. So that will implies that d squared will be d squared over dx squared. So you do the substitution. So this d squared over dx squared is d squared, then it is times the u which is there, then plus 2 d dx is d. So it is d times the u which is there, du, then plus 5u is equals to 0. Now you substitute d with the m, isn't it? To get the auxiliary equation. So where there is d, you substitute with m, then you get m squared u plus 2mu plus 5u is equals to 0. So from here, u is now a common factor. You can factorize out. Here you cannot factorize out because d is the derivative with respect to the independent variable there, x. So here you can now factorize out to u. Then you get m squared plus 2m plus 5 is equals to 0. So this implies either u is equals to 0 or the second equation is equals to 0, isn't it? So when this u is 0, it means the differential equation does not exist, isn't it? So it is this second factor, the m squared plus 2m plus 5 is equals to 0. Are we together? So, for those who have understood the concept, it implies that there is always no need of going all these steps to get the complementary function. You can always just come and say this is m plus 2 m plus 5, isn't it? Then you found the complementary. You found the auxiliary equation. Are you seeing that? So after that, if you solve for m, what do you get? M is minus b plus or minus square root of 4ac over 2a, isn't it? If you solve that, what do you get? Substitute. So m is supposed to be is 2, so minus 2 plus or minus square root of, what is this? This is b squared minus 4ac, isn't it? So what is b squared? That is 2 squared. You get 4 minus 4 times a times c, 4 times 1 times 5 minus 20, isn't it? Over 2 times a, 2 times 1, you get 2. What is m? What is m? So there you will find m to be equals to negative 4 minus 20 is negative 16. So it is plus or minus 2 into root negative 16 over 2, isn't it? So that is what? That is negative 2 plus or minus root 1 times root 16 over 2, isn't it? So square root of negative 1 is j. So it is minus 2 plus or minus j into root 16 is 4, isn't it? Over 2. So you get negative 2 over 2 plus j 4 over 2, isn't it? Are we together? So what is m? What is m? M is clear. 2 divided by 2 you get negative 1 plus or minus 2j. 4 divided by 2 you remain with the 2j, isn't it? So what is our u? The complementary function. When you have a real and imaginary, what is the form of the complementary function? It is going to be a cos beta x plus b sine beta x all into exponential alpha x, where this one means your solution here was in the form alpha plus or minus beta j, isn't it? So it means alpha, which is the real part negative 1, is going to the exponential function. Are you seeing that? Then your beta here, the component of the imaginary part 2, will now come to the trigonometric function. Are you seeing that? Are we together? So you can see our alpha is negative 1, the real part, it will be there. Then our beta is 2, the component of the imaginary part, it will go to the trigonometric function. So we get u is equals to a cos 2x plus b sine plus b sine 2x exponential negative x, because alpha is negative 1, isn't it? Are we together? So here we have found u. We have found u. After getting u, we now get v, isn't it? The particular integral. So the particular integral we have there is d squared v over dx squared plus 2 dv over dx plus 5 5v is equals to 34 cos 2x. This one, isn't it? So what is your choice for v? Your choice for v, you look at the function, isn't it? Here we have cos 2x. So if we have cos 2x, meaning our choice for b is supposed to be what? Here we've already used a and b. So we can use c and b or k1 and k2, isn't it? Are we together? So you have k1 sine 2x plus k2 cos. Are we together? See, that is according to the function here. The function is 34 cos 2x, but we are not interested in the constant part. We are only interested with the function which is there. This constant is now the case, isn't it? So cos, whether you have cos 2x or sin 2x, both of them you must test both of them which one is going to remain, isn't it? Are we together? Whether it was sin 2x, we are going to still have k1 sin 2x plus k2 cos 2x. Whether it is cos 2x, it is still going to be the same thing. Are we together? Because the sine and the cos, they go together according to the predictions of the complementary function, isn't it? Are we together? Yes. Then you check, is cos 2x in the complementary function? Is cos 2x in the complementary function? Yes. We have cos 2x. Yes. Huh? Yes. Hello? Yes, yes. Look here. This is not cos 2x. Remember, it is cos 2x times exponential negative x. So it means here, we don't have just cos 2x. We have cos 2x exponential negative x. Are you seeing that? Yes. Isn't it? And our function we have just cos 2x. It is not a product of cos and exponential, isn't it? Are we together? So it means cos 2x is not in the complementary function. Are you seeing that? This is not just cos 2x, it is cos 2x times exponential negative x. See this exponential negative x outside? Remember, when the solution, you would have found the solution of m to be plus or minus 2a. If this is the solution of m, then it means your u would have been what? Would have been a sine 2x plus b cos 2, because there's no real part, exponential 0. Are you seeing that? Are we together? So if this was your solution of u, because the real part is missing, it means there's no exponential function. So it means when you check, is cos 2x here? It is there. Are you seeing? Because it is not a product of cos 2x and exponential function, isn't it? Are you seeing that? Are we together? Yes. So it means when it is there, you are going to add x, isn't it? But here, we have, it is cos 2x exponential negative x. That's not cos 2x alone. Are you seeing that? Yes. So you have to check that. And remember, it is the function which is guiding us. It is the function which is guiding us. If that function f of x should have been maybe 34 cos 2x, maybe exponential x. Are you seeing that? Meaning, your choice for v would have been what? Would have been k1 cos 2x plus k2 sine 2x into exponential x. Are you seeing that? If you would have had your function of x, this function here to be this. Are you seeing? Meaning you are going to choose v to be k1 cos 2x plus k2 sine 2x exponential x. Is when you check you check. Is, after this you check, is cos 2x exponential x in the complementary function? No, isn't it? Then you check again. Is sine 2x exponential, either of them, isn't it? Either this or that, if any of them is there. Let's say this was negative. Let's say this was negative in the function, isn't it? Then if you check, is cos 2x exponential negative x in the complementary function? Yes, it is there. Are you seeing that? Then what do? You add x to them. Are you getting the argument? Yes. So you found the choice of v. So we start differentiating it, isn't it? If you differentiate for the first time, with respect to x, what do you have? Start differentiating. If you differentiate sine 2x, you get cos 2x. Then if you differentiate 2x, you get 2. So it is 2k1 cos 2x. Then you go again. If you differentiate cos 2x, you get negative sine 2x, isn't it? Then if you differentiate 2x, you get 2. So it is negative 2k2 sine 2x. Are we together? Then you move to the next one. D squared v over dx squared. Is that okay? Then you start. If you differentiate cos 2x, you get negative sine 2x. Then if you differentiate 2x, you get 2. So negative 2 times 2, you get negative 4k1 sine 2x, isn't it? Are we together? Remember, the whole of this negative 2k2 is a constant. All we are differentiating is sine 2x, isn't it? If you differentiate sine 2x, you get 2 cos 2x. So 2 times negative 2k, so you get negative 4k2 cos 2x. Are we together? Then now substitute it back in our equation. D squared v over dx squared, what have you found it? You found it to be minus 4k1 sine 2x, then minus 4k2 cos 2x. That is this, isn't it? Then it is plus 2 dv over dx, meaning positive 2 times dv over dx, meaning this your dv over dx, you multiply all of it with positive 2, isn't it? Are we together? It is positive 2 times the whole of dv over dx, so you get 2 dv over dx, isn't it? So positive 2 times 2, so it is plus 4 k1 cos 2x. Positive 2 times negative 2, it is minus 4 k2 sine 2x. Are we together? Then you are done with that. Then it is plus 5v, meaning v you multiply by positive 5, isn't it? See, this is the value of v, v is the whole of this. So you multiply the whole of this by positive 5, isn't it? So 5 times k1 sine 2x, you get plus 5 k1 sine, isn't it? Then you move on. 5 times k2 plus 5k2 cos 2x. Then the whole of this is equals to what? 34 cos 2x. Are you now seeing that? Meaning you can now compare the coefficients. You can now compare the coefficient. What I need you to be careful is this kind of equation. When exponential function was not there, you would have had x cos 2x, x sine 2x, isn't it? When exponential function was not there. Are you getting the concept? Because it means that we now add cos 2x, which was in the complementary function. Are you see? But now cos 2x is not in the complementary function. We have cos 2x times exponential negative x. You have to be very careful with that. Are we together? Is that understood? Yes. Good. That must be understood. So start comparing the coefficient. Meaning the other side we have 34 cos 2x. Meaning the other side we have 0 sine 2x. That's why sine 2x is not on the other side of the equation, isn't it? Are we together? So let us start comparing the coefficients of cos 2x. Tell me the first one. The first coefficient of cos 2x is what? See this. We have cos 2x is here. The first coefficient is what? Negative 4. Negative 4k2, isn't it? The next coefficient of cos 2x is this, isn't it? Positive plus 4k1. Then the next is only that. Are we together? Then on the other side of the equation, it is equals to the other side of the equation, so we have cos 2x here. What is its coefficient? 34. It is the coefficients you are comparing, isn't it? Meaning the coefficients of cos x on the left hand side of the equation is equals to the coefficients of cos x on the right hand side. There's another one. This one. Oh, there's another one. Which one is that? This. That is positive 5k2. Very good. To be equals to 34. Are we together? So you've checked, you collected all the coefficients of cos 2x. These are 3 and I'm seeing, or there are 3. 1, 2, 3, isn't it? Are we together? Yes. So if you simplify that, what do you get? Minus 4k2 and plus 5k2, you get You just get k2, isn't it? So this will simplify with us, you just remain with 4k1 plus k2 is equals to 34, isn't it? Are we together? Move to the next one. Collect the coefficients of sine 2x. The first coefficient of sine 2x is this, isn't it? Are we together? So this is the first coefficient of sine 2x. The next coefficient is this, isn't it? Then the next coefficient of sine 2x is that. Is there any other? See, there are only those three. Are we together? Are we together? So the first coefficient of sine 2x is negative 4k1. The next coefficient of sine 2x is negative 4k2. The next coefficient of sine 2x is positive 5k1. So if you simplify, what do you get? Negative 4k1 plus 5k1, you get a total of k1, isn't it? Then minus 4 k2 to be equals to, what is the coefficient of sine 2x on the other side? 0. That's why there's no sine 2x on the other side of the equation, meaning its coefficient is 0, because 0 times anything is 0, isn't it? Are we together? Can you now solve the simultaneous equation? So here we have the coefficient of sine 2x here is negative 4k1 and positive 5k1, giving you a total of k1, isn't it? Then we have minus 4 k2. Then on the other side of the equation, there is no coefficient 2x, meaning its coefficient is, and the first one here we found was 4 k1 plus k2 is equals to 34. Solve the simultaneous equation. So let us solve. How do we solve this? You can use elimination or substitution, isn't it? So what do we have here? If you take 4k to the other side, see, you will find that k1 is equals to 4k from this first equation, isn't it? k1 is equals to 4k2. So in the second equation, you have 4k1 plus k2 to be equals to 34. So I'm saying 4k1, meaning 4 times k1, because k1 is 4k2. You substituted, isn't it? Are we together? So what do we have? Solve that. 4 times 4? 16 k2, isn't it? So 16 k2 plus k2 is equals to 34, isn't it? So 16 plus 1, you get 17. K2 is equals to 34, isn't it? Very simple. So you divide both sides by 17, you get K2 is what? Is 2. So you found the value of K2, isn't it? And what is K1? K1 is 4 times K2, isn't it? So 4 times 2, you get K1 to be 8. 4 times K2. 4 times the value of K2. So having found K1 and K2, ladies and gentlemen, you are now very happy, because your V was K1 cos 2x plus K2 sine 2x, isn't it? Are we together? So this was your V. So where there is K1 and K2, you put the value of K1 and K2, isn't it? You put the value of K1 and, so what is the value of K1? 8. So you'll have 8 cos 2x plus K2 plus 2 sine 2x. So you found the value of V. Now, having found the value of V, and we've also found the value of U, meaning we can now get the value of Y. So you found V to be equals to 8 cos 2x plus 2 sine 2x. So give me the value of Y. The value of Y. Y was U plus V. So Y is equals to, what was U? U was A cos 2x plus B sine 2x into exponential negative x. Then it is plus V. What have you found to be V? 8 cos 2x, isn't it? plus 2 sine 2x. So you found y. After getting y, it means this is our final solution. So all we need is to put the boundary conditions to get the values of the constants a and b, isn't it? Are we together? We put the values of the boundary conditions to get the constants a and b. So you can see in the boundary condition when y is 18, is x is 0. Then when dy over dx is 0, x is also, meaning at x 0, dy over dx is 0 and y is 18, isn't it? Meaning we need to find the derivative of this so that we are able to put the value of dy over dx, isn't it? Are we together? So if you differentiate y with respect to x, you get dy over dx. If you differentiate cos 2x, you get negative 2 sine 2x. Differentiating cos 2x gives you negative sine 2x. Differentiating 2x gives you 2. So at the end, it is negative 2 sine 2x. So here we have negative 2a sine 2x. If you differentiate sine 2x, you get 2 cos 2x. You must differentiate both in and outer function, isn't it? So 2 cos 2x times b, you have plus 2b cos. No, there's a problem. There's an exponential outside. Have you seen that? There's an exponential function. See, that is now integration by parts. That is integration by parts. Yeah, what we are doing is right, but now you let this whole first part, this is to be u, integration by parts, this to be u and this to be v, isn't it? So it is like I've taken exponential negative x step, I'm differentiating what is inside. I'm still getting what I was getting, yes. So I have negative 2a sine plus 2b cos 2x, then exponential negative x, I took step, isn't it? Now, it is now plus, now I'm now taking this step, I'm differentiating exponential negative x. See, that is the integration, I'm differentiating exponential negative x. That is differentiation product rule, isn't it? The first thing, I've differentiated this function, taking exponential negative x step, isn't it? Now it means I'm now taking this step and I'm now differentiating exponential negative x, isn't it? When I differentiate exponential negative x, I will get negative exponential negative x, isn't it? When you differentiate in a function negative x, you get negative 1. So negative 1 times exponential negative x, you get negative exponential negative x. So it is minus, this one I took step a cos 2x plus b sine 2x exponential negative x, isn't it? So I have used the product rule to differentiate a product of two functions, meaning the whole of this bracket I'm considering to be 1, isn't it? Are we together? So when I differentiate this, I got this, then times that step. Then now it is plus, I now take the whole of this step and I differentiate exponential negative x, then I go to negative exponential negative x, isn't it? Then go here, if you differentiate 8 cos 2x, you get minus 16 sine 2x. If you differentiate sine 2x, you get plus 4 cos 2x. Those are now work off, isn't it? There's no longer product rules there, isn't it? So start substituting. Start substituting. Hello? When y is 18 at x is 0. So let us substitute there. Where there is y, we put 18. So we have 18 is equals to, while there is x is equals to 0. What is cos 0? 1. 1 times a. So you remain with a here. Since 0 is 0. So it means the whole of this bracket will remain with a, isn't it? Then exponential 0. Anything raised to power 0 is 1, isn't it? So it means the whole of this term will just remain with a when x is 0, isn't it? Then you come here, cos 0 is 1. 1 times 8 plus 8. Sine 0 is 0. The whole of that goes to 0, isn't it? We are done with that. So what does this imply? It implies a is equals to 10. If you take it the other side, isn't it? Are we together? Go to the second one. dy over dx is 0. While there is dy over dx, you put 0 then. X is 0. So sine 0, this will be 0, isn't it? This will be 0. Then cos 0 is 1. You remain with the 2b, isn't it? Then outside exponential 0 is 1. So it means the whole of this will remain with the 2b. Then we have here minus, then cos 0 is 1. See that one you remain with a. Sin 0 is 0, meaning the whole of this bracket you remain with a. Then exponential 0 is 1, meaning the whole of that term you remain with a. Are we together? Sin 0 is 0, so 0 times everything is 0, isn't it? Cos 0 is 1, so 1 times 4 you remain with plus 4. So what is b? What was your a? A is 10. Where did you say put 10? Where did you say you put 10? So what is b? You get 2b is 10 minus 4. Negative 10 going the other side, positive 10, positive 4 going the other side is minus 4, isn't it? So in the end, you end up with b to b 3. 10 minus 4 is 6. You divide both sides by 2, isn't it? So you found the value of A and B. Having found the value of A and B, ladies and gentlemen, it means you found the solution, isn't it? So the solution of y is what? It is a cos 2x, meaning it is 10 cos 2x. Are we together? It is 10 cos 2x plus 3 sine 2x. Then the whole of that is multiplied by exponential negative x. Then it is plus 8 cos 2x. Then it is plus 2 sine 2x. And you have solved the differential equation using the method of undetermined coefficients. So that is how to handle such kind of problems.